Hello! In this session, I'm going to talk about even and odd function. Odd and even functions are two types of functions that satisfy particular symmetry relations. In math definition, if for any x belong to domain of a function f, if minus x or negative x also belongs to domain of f, and f minus x is equal to fx, f is called even. On the other hand, if for any x belongs to domain of f, if again negative x belongs to domain of f and f minus x is equal to minus fx, this is called odd function. If we take a look at even and odd functions graph, suppose that this is x, y, and if this is a function like fx, so, and this function is an even function. Why? Because for any x, the negative, for example, x0, the negative x0 also belongs to domain of the function, and f minus x0 is equal to fx0. So this is fx0, at the same time this is f minus x0. So this is this fx is an even function. Basically f is symmetrical about the y-axis. On the other hand, if this is gx, this is an odd function. Why? Because again, for any x0 belongs to domain of g, minus x0 belongs also to domain of g, but if this is gx0, and this is going to be, for example, g minus x0 is equal to the negative gx0. So g is going to be an odd function, and we can easily see it's symmetrical about the origin. Now let's take a look at some examples. Example number 1. Suppose that fx is equal to 5x4 plus 3x2 plus 4. Is this function even or odd? First, the domain of this function is R, it's a set of the real numbers. So for any x belongs to domain of this function, the negative x also belongs to domain of the function. So for any x, negative x also belongs to domain of function. And f minus x, clearly we can see is going to be 5 minus x to 4 is going to be equal to x to 4 plus 3, and again minus x2 is equal to x2 plus 4. We can clearly see f minus x is equal to fx, so f is an even function. Example number 2. Suppose that gx is equal to x3 plus x. Again, like first example, for any x, negative x also belongs to domain of g. So the first condition basically satisfies, and we can clearly see g minus x is equal to minus x3 minus x, which is going to be minus x3 plus x. This is gx. So g minus x is equal to minus gx, meaning g is an odd function. Let's take a look at another example. Suppose that hx, example number 3, is equal to x3 plus x2 plus 1. Again, the domain condition satisfies, but h minus x is equal to minus x3 plus x2 plus 1. We can clearly see this is neither equal to hx nor minus hx. So this function h is neither even nor odd. This is just a function. Have a good day.